Hello viewers, welcome to Quick Mathematics. The problem is to expand bracket open a plus b bracket close to the power of 50. We have a binomial expression with a very high power. Let us take the quick solution. Before then, if you are new to this channel, please subscribe and turn on the notification bell so that you will be the first to be notified anytime there is an amazing video such as this from me. Solution: we have the given expression. It is binomial, two terms expression. The first term is A, the second term is B. To expand, you start with the first term and you assign the given power 50 to it. At this point, the power of the second term is 0, so that the sum of the two powers is 50. B power 0 is 1. We are left with A to the power of 50. Here, the coefficient is 1. So, we have the first coefficient equal to 1. The second coefficient for the second term is the previous coefficient, 1 times the power of the first term, 50, and that is 50. At this point, the power of A will decrease from 50 to 49, and B will increase from 0 to 1. The third coefficient is the previous coefficient, 50 times the power of the first term, that is 49 divided by 2. Divide by 2 because before here the first term has occurred 2 times, that is 1, 2. The coefficients are generated using the coefficient and the power of the first term only. Divide by how many times the first term has occurred before that point. You have these results. The power of A will decrease from 49 to 48, and B will increase from 1 to 2. The fourth coefficient is previous coefficient times the power of the first term. The first term is used only, that is 48 divided by 3. At this point, the first term has occurred 3 times. That is 1, you have 2, and 3. That is the 3 that you have here. You have this result. Note the decrease and increase in the powers of A and B. You have the fifth coefficient equal to this. You have this result. Sixth coefficient equal to this. You have this result. Seventh coefficient equal to this. You have this result. Again, note the decrease and increase in the powers of A and B. This is the 8th coefficient. Follows by this result. The 9th coefficient is equal to the previous coefficient times the power of the first term, 43 divided by 8. Divide by 8 because before here the first term has occurred 8 times. follows by this result. You have the 10th coefficient follows by this result. 11th coefficient follows by this result. 12th coefficient follows by this result. 13th coefficient follows by this result. 14th coefficient follows by this result. 15th coefficient follows by this result. 16th coefficient follows by the next result. 17th coefficient is equal to the previous coefficient times the power of the first term. At this point, 35 divided by 16. Divide by 16 because before here, the first term has occurred 16 times. You have this result. Once again, note the decrease and increase in the powers of A and B in the next term. The next term, the power of A will decrease, the power of B will increase. 18th coefficient equal to this follows by this result. 19th coefficient follows by this result. 20th coefficient follows by this result. 21st coefficient follows by this result. 22nd coefficient follows by this result. 23rd coefficient, that is the previous coefficient times the power of the first term. At that point, 29 divided by 22. 22 because before here, the first term has occurred 22 times. You have this result, then 24th coefficient follows by this result. 25th coefficient is equal to the previous coefficient times the power of the first term. At that point, 27 divided by 24. 24 because before here the first term has occurred 24 times. Follows by this result. 26th coefficient follows by this result. Once again, note the decrease and increase in the powers of the first and second term. 27th coefficient follows by this result. 28th coefficient follows by this result. 29th coefficient follows by this result. 30th coefficient follows by this result. 31st coefficient follows by this result. 32nd coefficient follows by this result. 33rd coefficient is equal to the previous coefficient times the power of the first term. At that point, 19 divided by 32. 32 because before here the first term has occurred 32 times. Follows by this result. 34th coefficient follows by this result. 35th coefficient follows by this result. 36th coefficient follows by this result. 37th coefficient follows by this result. 38th coefficient follows by this result. 39 coefficient follows by this result. 40th coefficient, which is the previous coefficient times the power of the first term. At that point, 12 divided by 39. 39 because before here, the first term has occurred 39 times. Follows by this result, we have the next coefficient equal to this, follows by this result. 42nd coefficient follows by this result. 43rd coefficient follows by this result. 44th coefficient follows by this result. 45th coefficient follows by this result. 46th coefficient follows by this result. 47th coefficient follows by this result. 48th coefficient, that is equal to the previous coefficient times the power of the first term at that point, 4 divided by 47. 47 because before here the first term has occurred 47 times. Follows by this result. 49th coefficient follows by this result. 50th coefficient follows by this result. At this point, the power of the first term is 1, second term 49. If you obtain the next coefficient, that is 50 times 1 divided by 50, you have 1. The power of the first term will decrease from 1 to 0. The second term will increase from 49 to 50. So this term A power 0 is 1. You are left with B to the power of 50 as the last term of the expansion. Next, we put everything together to have the final result. This is the given binomial expression. At the end, you put all the terms together from each stage of expansion and you have this result. One thing you must note is that the first term to the given power will begin the expansion and the last term to the given power also will end the expansion. You must not forget that.